In computing, faculty play many critical roles. The composition of the academic workforce thus shapes what advances are made and who benefits from them. However, despite a continued emphasis on broadening participation, women and people of color remain underrepresented relative to population. Now, a group of researchers have some new ideas to address this. Join us as we speak with LaBerge at the University of Colorado Boulder to discuss subfield prestige and gender inequality among U.S. computing faculty.
The goal of this project was to better understand how subfield hiring choices can shape the demographics of faculty in computing. We estimate that women's representation among computing faculty is increasing at only 0.2% per year, such that men and women will not be equally represented for over 100 years if current trends don't change. We were interested in better understanding why progress is so slow, despite ongoing efforts to increase diversity.
The faculty hiring process is an important step to becoming a professor, and the study found that most faculty job openings are subfield specific.
A department may conduct a faculty search in machine learning and only consider applicants in that subfield. As a result, the field-level demographics like gender, racial, and socioeconomic representation are in fact driven by diversity differences across computing subfields. For example, faculty searches in subfields with fewer women are less likely to increase a department's gender diversity.
In practice, faculty hiring closely follows a prestige hierarchy, in which highly prestigious departments train a disproportionate share of all computing faculty.
High prestige departments have a correspondingly large influence over the field's demographics, and efforts to understand patterns, trends, and causes of demographic diversity in computing must account for the effects of prestige. Moreover, we find that faculty in the less gender-diverse group of subfields are more highly concentrated at the most prestigious universities, which are known to produce an outsized share of future faculty. And we find that the more traditional subfields tend to be roughly 25 years behind the other group of subfields in terms of gender representation.
The differences in gender diversity that were found across the subfield structure of computing suggest a simple strategy that a department could use to enhance its probability of hiring women faculty.
And that is to increase hiring in the subfields with greater gender diversity, such as human-computer interaction and interdisciplinary computing, or avoid restricting the faculty search to a specific subfield altogether. However, this strategy is unlikely to increase racial or socioeconomic diversity, as these faculty characteristics do not appear to correlate with subfields in our sample.
While the understanding of diversity within computing faculty has advanced, further questions and findings surely remain necessary.
The computing community needs to explore several questions before these findings can be translated into concrete policy recommendations. Most importantly, I hope that future research can identify the causal mechanisms driving gender differences across subfields. This project helps map out the current demographic landscape of computing faculty, and I'm particularly passionate about seeing this map get used to inform and support multifaceted efforts to make computing more diverse, equitable, and inclusive.
Find out more in Subfield Prestige and Gender Inequality among U.S. Computing Faculty, a contributed article in the December 2022 Communications of the ACM.